Going to the cloud. Up. I am slow motion today. Hello, how are people at home, Terrence and Mr. Carter?
Well,
All right. Doing better.
Good. 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 Did they figure out everything that was going on?
Yep.
Okay. Good. Okay. And then I want to go. I'm trying to open all of the stuff that I'm using, so I apologize for being slow. Blackboard. And log in. And book. And it's warm in here, isn't it? I wonder how long it was cold in here, and now it's warm. Oh. There goes my trying to look like a grown-up in dress clothes. All right, you know there's a problem when I'm using the desktop mouse to try to move the Chromebook. At home for notes, I use a touch screen, and I write on the touch screen as if it were a dry erase board. And so then I go to take attendance on this, and I'm like touching the screen, and it's like, no, the $100 Chromebook from Target does not have a touch screen. Okay, so we have Lance with us today. We have Terrence with us today. We have Suzanne. I almost called you Patricia, Suzanne. I'm so sorry. Suzanne with us today. We've got about a minute before starting, so I'm going to go down here and open ImageMate with the announcements for folks at home, and that statistic test due the 6th, that's with an asterisk next to it. Let's talk about it. I was going to go over the review today. Is it better for you to take the review the week after the test, or did you still need to tie up loose ends with some of that homework, and would you rather have the test on the 13th? In between times, we're definitely starting that next chapter. Does it make a difference to you? Okay, folks at home, does it make a difference to you if the test is the 6th or the 13th? We're going over the review sheet today, and we're starting the new chapter either way. Is kicking the can down the road better, or is it having it closer to the review better? At home, can you guys hear?
Let's say closer to the review.
Okay, so then we'll leave that at the 16th. People who were here early on time, your voices count more. So there we go. So then I'm going to stick by everything that's there. So the test is in My Labs. You're going to submit the work in Blackboard. Do not pay attention to the My Labs grade. It will definitely change when I look at your work in Blackboard. It's the grade in Blackboard that's going to matter. I have to apologize for those of you who did the quiz over the weekend, because you had theoretically until last night. I waited till today to grade it, and today My Labs all day long did not like me. It would not let me in. It worked very slowly. If that was a problem for anybody and they didn't get something done because My Labs was acting pissy, let me know and I can move these due dates. So let's see, where are we going today? First thing we have to do is look at that last topic, which is margin of error. And then we'll go over the review for the exam. And then hopefully the start of this next unit will be a breath of fresh air for everybody, because we're just looking at percents and simple interest. I don't think we're going to get as far as compound interest today. But the last statistics topic, oh, wait, I lied. Man, I'm a jerk. What do you guys want to look at from my lab? Does anybody want to look at anything from the homework? Or I think I promised somebody that we would go over that quiz from the weekend, the mean, median, and mode quiz. Before we look at the quiz, does anybody, the central tendency quiz? Should we do that first and then look at the homework? Yeah. Okay. So looking at the quiz, again, my numbers are going to be a little bit different than yours. First question asks us to find the mean, and the list of numbers that we have are 58, 55, 57, 50, 55, and 61. I'm going to switch to ImageMate so that we can look at the work together. In order to find the mean, what we have to do is we have to add those values. And I guess I'm owning up to being not the world's best math teacher, because I'm going to cheat and use a calculator to find them. Those total to, let's see, what do I get? I get 58 plus 55 plus 57 plus 50 plus 55 plus 61. And so those add up to 335, and there's 1, 2, 3, 4, 5, 6 of them. So when I divide that by 6, I get the mean is 55.83333. Is everybody getting that number? What are you getting? Did you add up, did they add up to 335, or did I type them in wrong? Oh, I did type them in wrong. They add up to 61. And so you're right. They add up to 36. You're right. And so the average is 56. You've got it. I messed up. I typed the number wrong. Okay? That question all right for everybody? Then next one asks us to find the median, and the median is of the numbers 8, 13, 6, 5, 12, 7, 14, and 11. And in order to find that median, what I have to do first is I have to, get rid of that scribble that I put on the page. Is it going to let me? You can't see what the computer screen is showing, but sometimes the mouse turns into a pencil in ImageMate, which is the thing that shows the document camera. So there's a big scribble across it. To find the median, I have to put them in order first. So the smallest number is 5, then 6, then 7, then 8, then 11, then 12, then 13, then 14. We've got 1, 2, 3, 4, 5, 6, 7, 8 numbers. 1, 2, 3, 4. 1, 2, 3, 4. So the median is halfway between the 8 and the 11. So I'm going to take their average. 8 plus 11 divided by 2 would be 19 divided by 2 would be 9.5. How's that one? Folks at home, are you all right?
We have different questions for the quiz, or is it all the same questions?
The numbers change. Everybody has different numbers. The question should be the same, but the numbers change.
Just making sure.
Next asks us to find the mode. Here, I'm going to be lazy and not copy it over to separate paper. The mode is the number that occurs most often. And as I'm looking at these list of numbers, I see 8.5 is there twice, and I see 6.8 is there twice. I don't think any other numbers repeat, and so we have two modes, both 8.5 and 6.8. Is everybody all right with that one? Then question 4, find the mid-range. The mid-range, again, is the highest number plus the lowest number divided by 2. And so as I look at the set of numbers, I think 84 is the smallest and 90 is the largest. So we'll take 84 plus 90, which gives me 174. And when I divide it by 2, I get the mid-range to be 87. That one all right. Next one then asks me to fill in this frequency distribution. And for the frequency distribution, I need to see how many there are of each data value. So as I look at the 15s, I've got 1, 2, 3, 4, 5 15s. Are my eyes okay? Is everybody else counting 5 15s? And then is everybody all right with the frequency distribution finishing it? So I'm going to leave this one be. And then with the stem and leaf diagram, the one thing you have to be careful of is this question asks you to put the leaves in order. And so for the stem and leaves, let's look at when the stem is 2, I'm looking for how many of these numbers are in the 20s. And over here, I have plain old 20, I have 24, I have 22, and I have 29. So in order, I have 20, 22, 24, 29. And in the same way, we need to go through the whole data set. Is everybody all right with the stem and leaf diagram?
Yeah.
We good? Okay, so feeling better about the quiz? And again, I made a silly computational error. If I can see that you made a silly computational error, you will get more than half credit. Okay? Then let's get out of there and see if anybody wants to look at any of the homework, because I know what we did last class, using that normal distribution, finding the z-scores for the percentiles, and also using that 68, 95, 99.7 rule. That's some of the more rigorous statistics that we're going to do this class. I think the mean, median, mode, mid-range is within everybody's comfort zone. The standard deviation is just a process. Just be careful going through. Remember all of the parts that you need to do. But now applying that standard deviation with the z-scores and finding percentiles, that's where we get into some upper level statistics. So does anybody want to look at any of those? At home, folks, did you have any questions on any of the MyLabs homework?
I'm good.
No.
You're good? Okay. No questions? Okay, then I am going to back out of here. And did you notice MyLabs wasn't acting slow?
Yes, it was.
This
It
more,
was crazy for me all day. I've been trying to catch up, and it just wasn't letting
I'll
me.
tell you what, because it's freezing for everybody all day, what I'm going to do is everything that's due today, when I get home, I'll bump those due dates back a couple, because I know that it's been very aggravating. And I apologize. I should have sent you guys an email. I complained. The head of the department called our Pearson representative, and she said that it's not just us, it's Pearson across the country. So there's, I apologize, that's beyond your control. So I will go through and kick the can down the road. If I give you guys, for these 2 assignments, if I add 2 days, will that be enough? And I apologize for not sending you an email when I got that communication from sales this afternoon. But by the time I got it, it was late enough in the day that I was running around like a chicken with my head cut off. I'm sorry, I didn't email you. So, all right, then, if there's no questions on what we've done, the last thing that we're going to look at in statistics, which actually is a part of that homework 17, is we're going to look at something called the margin of error. And have any of you ever, you see it most often near election day, when they start showing poll results. And they say so-and-so's got this % of the vote, so-and-so's got that % of the vote, but there's a margin of error. The margin of error shows up because what happens is we use samples.
I can't see your screen.
You can't see oh my God, you couldn't see my screen when I was sharing my labs? Because I've been, every second I've been popping up so that it would show for you guys, and I forgot to hit share screen. Oh my God, and there's 5 people in the waiting room. Let me admit them too. Whoa, I'm a jerk. Hopefully they were waiting patiently. So the margin of error occurs when we use samples to estimate values for the population. And when I use a sample to estimate for a population, does it make sense to say that the larger the sample, the more accurate the estimate is? And in the opposite direction, the smaller the sample, the less accurate the estimate is. If I survey thousands of people, I'm going to have results closer to the population than if I just surveyed 10. And so does it make sense that the margin of error involves the sample size? And the margin of error also involves how accurate you want to be. If you take a statistics class, you're going to find that there's different ways of computing the margin of error depending on how accurate you want to be. Mr. Blitzer, in his infinite wisdom, only has us look at one margin of error. And so for accuracy, we're only going to use a 95% level of confidence. And what that means is with the statistical methods that we're using, 95% of the time, our estimate region will include the population values. So 95% of the time, the interval we have from our sample will include the population values. We're also only going to be finding the margin of error for a percentage or a proportion of the population. And so the formula that we're going to use for the margin of error for 95% level of confidence is 1 over the square root of n times 100%, where n is the sample size. So for example, if I survey, let's say 100 people, the margin of error one over the square root of n times 100%. Well, the number of people here, n is 100. So my margin of error would be 1 over the square root of 100 times my 100%. And so with my calculator, to type that in, I'm going to take 1, and then to put it over, I'm going to use divided by. Then remember, for my square root, I'm going to first hit second and then x squared, and it gives me a square root symbol. So I'm take 1 over the square root of 100. I open parentheses for the radical. I have to close them. And now I'm going to multiply that answer by 100. And so my answer is 10. So if I only surveyed 100 people, my margin of error is 10%, which means my value could be up to 10% smaller or larger for the population. Instead, let's say this time we want to survey, let's survey a whole bunch more people. Let's survey 90,000 people. So because my sample size is much larger, you'd expect my error to be much smaller, I hope. And so here, n is 90,000. And so my margin of error is 1 over the square root of that 90,000. And then I'm going to multiply it by 100%. And so could everybody please type in 1 divided by the square root of 90,000 don't forget to close your parentheses, times that 100. And so now my margin of error is 0.33%. And you notice it's much smaller. I'm much more accurate because my sample is so much larger. Sure. So I'm taking 1 divided by, to get the square root, I'm going second x squared. Then I'm typing in my 90,000. I'm going to close my parentheses. And then to change that into a percent, I'm going to multiply it by 100. And so I get 0.3333. Did you get it that time? Okay. And so that's 1/3%. And so if I'm only off by 1/3%, 90,000 is a very good sample size, and I'm much closer. However, in real life, nobody takes the time to sample 90,000 people. It would be a lot. But those are just ideas on finding that margin of error. I have a handout that I created about how it's used with 2 problems from the virtual text, from the actual textbook. And I have to tell you that after I picked up these problems from the textbook, I went in my Zoom, my blended class, to look at the homework for another example and realized that these are the 2 almost identical to the problems on the homework. Hopefully these 2 suffice. Again, the textbook is a little old, so this data is dated. I would say that these survey results are probably somewhere between 10 and 15 years old. But question 67 on this handout, folks at home, can you see it? Can you read it? I'll scan it in so it will be in with today's notes.
Yes.
Says reducing gun violence. The data in the bar graph are from a random sample of 814 American adults. Okay, I'm going to stop. I know what type of the question this is. I see that number. That's my sample size. So let's write down that N is equal to 814. That's my sample size. The graph shows 4 proposals to reduce gun violence in the United States and percentages of surveyed adults who favored each of these proposals. So 69% thinks there should be gun registration, 58% thinks there should be a ban on high-capacity magazines, 56% thinks there should be a ban on assault weapons, and 52% thinks you should restrict the amount or type of ammunition that can be purchased. And yeah, it was an old survey, it's from 2013. Part A just asks me to find the margin of error to the nearest 0.1%. Well, the margin of error is that, I'm going to go up here for part A. The margin of error is 1 over the square root of n times 100. So that'll be 1 over the square root of 814 times 100. And so I'm going to take my calculator. 1 divided by second x squared gives me that square root symbol, 814. Since it opened parentheses, don't forget to close them. And then I'm going to multiply that by 100. And so to the nearest 0.1%, is anybody else getting something that looks like 3.5%?
Yes.
And so that means that my survey results could be 3.5% off in terms of estimating the population. the actual population value could be 3.5% lower, or 3.5% higher, or anywhere in between. And so Part B asks me to write a statement about the percentage of adults in the population who favor required gun registration to reduce gun violence. Well, gun registration is 69% on my bar graph. And from that, I can add and subtract my margin of error, 3.5%. And so when I take 69 minus 3.5, I get 65.5. And when I take 69 plus 3.5, I get 72.5%. And so while my sample said exactly 69% of the people I asked felt that way, if I want to generalize to the whole population, I'm going to say maybe it's not exactly 69%, but rather somewhere between 65.5% and 72.5%. Does that part, in terms of thinking about it, make sense?
Yes.
So then my statement is going to be that I'm 95% confident. And again, we are always going to be 95% confident because we're only using the formula for a 95% level of confidence. I'm 95% confident that between 65.5% and 72.5% of the U.S. population favor gun registration. And I'm going to say that when I used to give pencil and paper tests, I asked people to write that statement out. I guess you're lucky in my labs. In my labs, the statement's written out, and they just ask you to fill in the blanks with those two numbers. Okay? So, shall we look at that next example? I'm going to zoom out a little bit so I can actually fit the whole paper width here. And again, this is something that's probably even a little bit older. You guys are probably way too young to remember the television show MASH, but maybe you've seen them in reruns. Back in the day when MASH was on television, there were only across the country maybe 4 or 5 television stations and not the hundreds that there are now. And so when there were only 4 or 5 television stations, it was not uncommon for something special like the last episode of a popular program. You had a whole bunch of people watch it. And so this question says, using a random sample of 4,000 TV households, Nelson Media Research found that 60.2% watched the final episode of MASH. Part A asks you to find the margin of error, and Part B asks you to write a statement. Again, the margin of error is 1 over the square root of n times 100. And so I'm going to shut up and tweak attendance for those poor people that I left stranded in the waiting room too long, while you folks figure this one out. Oh, I didn't want to make it that big. Okay, so let's see. Anthony's with us. Bunny's with us. Yay, Bunny. Yay, Anthony. Morgan's with us. Mr. Carter, we've got. Terrence Pete is with us. Terrence, we've got. And we also have to add Kelly. Okay, now I think attendance is up to date. How did I do? Did anybody else get their margin of error to be 1.58 and then it went on? I rounded it to the nearest hundredth. On the homework, they'll tell you where to round. Did anybody not get the 1.58%?
I rounded to 1.6%.
Okay, because the question didn't tell you where to round, that's acceptable. That's perfectly fine if you use the 1.6%. If you use the 1.6%, then when I subtract the 1.6%, I would get, oh, I'm going to be really lazy. I'm sorry. Uh, 58.6. And when I add it, if I would have used the 1.6, you would have gotten 61.8, which would have been fine. But pay attention if the question has round off words. Again, this one didn't. So, and then is everybody all right with the statement? And again, you'll just be filling in those percentages. But it says I'm 95% confident between 58.62% and 61.78% of TV households watch that final episode of MASH.
Yes.
Okay, shall we try one more of these, pulling one off the homework? Or do you think we've got it? I think there's only 2 of them in the homework.
Practice is always good with me.
We're good, or we want another one? I couldn't hear what you said.
Yes.
Yes to another one, or yes, we're okay?
Yes to another one.
Okay. Well, then for another one, I'm going to, hopefully, my labs isn't going to yell at me. We'll see what they say. I think this is homework 12 point, no? I think this is in homework 17. Yeah. And I think these are the very last questions in homework, not quite the very last, but almost the very last. I think they're 26 and 27. 26 is the gun violence one, so let's see what 27 is. It's not MASH, it's a different television show. So the question here says, a random sample of 1,358 TV households, Acme Media Statistics found that 69.8% watched the final episode of I Can't Take It Anymore. Find the margin of error and write a statement. Let's just first find the margin of error. And so here, this is the homework example. The sample size is 1,358. So the margin of error is what? And here they want it to the nearest 100. What percent are you getting? Nobody's volunteering their answer. What? Oh, Lord. Well,
All right, 2.71.
that's no good because I wanted you guys to see the question I was reading. I didn't push the button. But did you get 2.71%?
Yes.
So, excellent. We did it. Now this next part says, I can be 95% confident that between blank and blank, watch the final episode. So what should we do with that 2.71? What should we add and subtract it from?
69.8.
69.8, the percent of our sample. So we're going to take 69.8% and we're going to add and subtract 2.71%. So 69 point, oh Lord. You know you're tired when you press the 3 instead of the decimal point. 0.8 minus the 2.71 gives me, is anybody else getting 67.09?
Yes.
And now I'm lazy, so I just arrow up and change my minus sign to a plus sign. And in adding, I get 72.51%.
Yes.
And yay, we did it. And so do you see what I mean? For you guys doing it in my labs, you don't have to write the sentence. You just have to fill in the percentages. Okay, guys? A little bit more confident in your level of confidence. Margin of error and all of that. Okay, then I'm going to back out of this assignment. And I need to push the button over here for you guys. Next thing that I'd like to do then is review what we've done. In order to review what we've done with statistics, the review sheet is available in Blackboard if you want to print it out and file again. or want to try it again on your own. But this is just the old pencil and paper test that I used to get. And so we'll use pencil and paper testing as a practice for the MyLab test. When I text the questions from MyLabs, obviously they're not identical to these pencil and paper questions because they don't talk about the Peace Bridge in Buffalo or things like that. Haven't they been talking for like probably longer than most of you people have been in existence about trying to rebuild the Peace Bridge? I know when my husband and I moved back to Western New York, that was the big thing in the news, the different designs they had for the new Peace Bridge. And that was before my youngest child was born, and she's turning 31 this year. So it's been a long discussion in Buffalo. So let's see what this question says. Says the Peace Bridge Authority wants to determine whether the residents of Buffalo support the concept of a signature span. They decide to conduct a survey of a sample of the city's residents. Which one of the following would be the most appropriate for obtaining a sample of the city's residents? To survey the occupants of every third car that crosses the Peace Bridge on any given day. To hold a public hearing and survey those who attend the public hearing. To survey a random sample of persons that live within each geographical region of the city. Or to place the survey on the city's webpage for a day for residents to respond to. Which looks like it would be the best way of getting a random sample, a sample where anybody in Buffalo would have an equal chance of getting picked. See? Because that's a random sample. If you look at something like putting it on the city's webpage, people have to choose to respond. And so that's one of those self-selected surveys. The best one here would be C. And if you can tell, the questions on the handmade test were very local. Question 2 says the annual average snowfall totals for a season in inches for 15 cities in New York State are 59, 33, 63, 95, 68, 105, 70, 83, 38, 64, 88, 95, 98, 76, and 100. We're asked to make a stem and leaf diagram of the data. Again, when it was the pencil and paper test, I wanted to make sure that you put a title. So annual snowfall in inches. And then I'm going to make a sloppy copy off to the side and then do my right one, my correct one. The smallest snowfall is in the 30s, so then we'll go 40s, 50s, 60s, 70s, 80s, 90s, and then we have one over at 100. Does everybody remember to make the leaves? My first number is 59, so next to the 5, I'll put a 9. 33, next to the 3, I'll put a 3. 63, next to the 6, I'll put a 3. 95, 68, 103, 70, 83, 38, 64, 88, 95, 98, 76, and 100. Is everybody comfortable with filling in their stem and leaf diagrams? Now, the reason that's my sloppy copy is because technically For my good one, I know my stems are in order from 3 to 10. Technically, we should order our leaves. So the leaves off the 3 are already in order. There's none off the 4, only one off the 5. Do you see the ones in the 60s? They're out of order. It should go 3, 4, 8. If they ask you to put them in ascending order, that's what they want you to do. The 70s are in order. The 80s are in order. The 90s are in order. But the hundreds aren't. We have to interchange the 0 and 3. And in my labs, that's all that they ask you to do. Is actually they'll have the stems for you and they'll ask you to put off the leaf. Pencil and paper by hand. I always also ask for a key, so that if there's somebody who never read one of these before, they might not be quite as clueless. And so I'm going to just take a random number. 3-3 is 33 inches of snow. Something just to say what the values represent. In addition to making a stem and leaf diagram on the test, like on the quiz, you're going to be asked to make a frequency distribution. The one on the pencil and paper test was a group frequency distribution. I have to apologize. I don't remember if the one I put in my labs is grouped or not. So the first class is 30 to 39. So the second class would be 40 to 49. Then 50 to 59, 60 to 69, 70 to 79, 80 to 89, 90 to 99, and 100 to 109. And then we're asked to put the frequency. The other thing that I miss in terms of a pencil and paper test is we don't have to redo the numbers, right? In my labs, each question gives you a new set of numbers. So because I've already got my stem and leaf diagram, I'm going to snag my frequency from there. From the stem and leaf diagrams, as everybody see, there are 2 numbers in the 30s. There are no numbers in the 40s, 1 in the 50s, 3 in the 60s, 2 in the 70s, 2 in the 80s, 3 in the 90s, and 2 in the hundreds. And again, if you hadn't made the stem and leaf diagram, hopefully everybody would be able to count those frequencies from the numbers listed. How are we feeling about this test so far? Would you have all aced that first page?
Yes.
Good. Second page asks you to make a histogram. And I do believe that in my labs, they don't have you draw the histogram. It's just guess, multiple guess, which is the right histogram. But here, let's draw it. We want a histogram for grades for students on a 10-point quiz. So my title would be Quiz Grades. As I look at this quiz, it looks like the lowest grade was a 6. So I'm going to put a break in my axis, and I guess I'll use 2 blocks for each number, 6, 7, 8, 9, 10, if you're drawing it by hand. What we look for is consistency in the spacing. And this would be labeled quiz grades. This would be my frequency. And I could label it frequency, or if I want, I could put number of students. And because this is a big piece of graph paper, I'm going to use 2 for each number. Now, when I count, I have a tendency to cross out numbers to make sure I didn't miss any. So how many 6s are there? 1, 2, 2 6s. So centered above 6, we'll have a bar with a height of 2. It's centered above 6. Remember, if you're doing it by hand, you want it to go from 5.5 to 6.5. Then 7s, there's 1, 2, 3 7s. So centered above 7, I'll have a bar of the height 3. There's only 1 8. So above 8, we'll have a bar of height 1. There's 1, 2, 3 9s. So above 9, we'll have a bar of the height 3. And then there's 1, 2, 3, 4, 5 10s. So above 10, I'll have a bar with a height of 5. Remember, to be a histogram, those bars have to touch. And to be a histogram, the data has to be on the horizontal axis and the frequency has to be on the vertical axis. That one all right?
Yes.
And then I have to apologize, this next question. Oh, it's rubbing salt in an open wound if you're a Sabres fan. But this, because it was dated in November, this data is rather old because they didn't even play last November. So it's a few years ago. But we've got the number of goals scored by the 5 highest at that stage in the season were 7, 7, 6, 5, 4. First thing that we want is the mean. And remember, to find the mean, we add up the numbers and divide by how many. So that would be 7 plus 7 plus 6 plus 5 plus 4. And we divide by 5. And so when I add those 14, 24, 29, divided by 5 would be, I think that's 5.8. Somebody check me on it. Thank you. So my mean is 5.8. For my median, I have to put them in order: 4, 5, 6, 7, 7. And the middle number here is 6. The mode is the number that repeats most often. So that would be 7. Be careful, the mid-range is one that people sometimes forget. It's the highest value plus the lowest value divided by 2. And if you're doing it with a calculator, remember to put parentheses around that addition before you divide. So that would be, my highest is 7, my lowest is 4, divided by 2. 11 over 2 is 5.5. Don't get that confused with the range. The range is just the highest minus the lowest. So that would be 7 minus 4, or 3. On the old school pencil and paper test, they were all part of one question and they all used the same data values. In my labs, there's nothing like that. So each of those is going to be a separate question. So initially, when you look at that MyLab test, it's got more questions than this. But realize in MyLabs, each of those is a separate question, as is the standard deviation. The one thing that I did always do on the pencil and paper test is have both the table and the formula for the standard deviation. They won't have that for you, but do you guys want me to put a little bit of a formula sheet in Blackboard, which will have a table, the formula, and the formula for the z-score, and the formula for, what else do we need a formula for? The margin of error. I don't think anything else needs a formula. So, well, I'll when I go home, I'll make that formula sheet and I'll email it to all of you, okay? So,
Thank you.
first column, I put my data values, 7, 7, 6, 5, 4. Second column, you don't need, but I find it convenient to put my mean in there, 5.8, which we found already. Next heading tells me I'm going to subtract those. So when I take 7 minus 5.8, I get 1.2. And I'm a little lazy, so when I fill this in, I fill it in going across. I just take that number that's in my calculator and square it to get 1.44. Next one's the same. Now when I take 6 minus 5.8, I get 0.2. And when I square 0.2, I get 0.04. 5 minus 5.8, well, that gives me negative 0.8. And when I square that, remember we're squaring to turn that positive. Squaring that will give me positive 0.64. Then lastly, 4 minus 5.8 is negative 1.8. So when I take that 1.8 and square it, I get 3.24. Now, I like to total both of these columns. This one, when I add the positive, I get 2.6. This one, when I add the negative, I get negative 2.6. So that column adds to 0. Now, that next column, I'm going to use my calculator to add. So let's see, 1.44 plus 1.44 plus 0.04 plus 0.64 plus 3.24. That adds to 6.8. Now, this is the one place where I use the big bad formula, because the big bad formula tells me to divide by 1 less than the sample size. And so if I go over here to find the mean, I knew that my sample size was 5. So I'm going to take that 6.8 and divide it by 1 less than that 4. And so that gives me 1.7. And now to finish it, I'm going to take the square root of that. And when I take the square root of 1.7, I get 1.3. Again, in my labs, they'll have rounding words for you. Here, 1.3 is a great place to round to, because my original data was all whole numbers. And so we said we were only going to round one place beyond the original data. So it would be 1.3. Is everybody all right with that standard deviation process? Then next question says the mean height for adult women is 65 inches with a standard deviation of 3.5 inches. find the height that represents 2 standard deviations below the mean. Well, that means I'm going to take my mean. Below means I'm going to subtract 2 of my standard deviations. My mean is 65, and I'm going to subtract 2 times my standard deviation is 3.5. So 65 minus 7 would give me 58 inches. 3 standard deviations above the mean. The above tells me to add. So I'm going to take my mean and add 3 times the standard deviation, which I think gives me 75.5. But you guys are very brave if you trust me doing that in my head. 65 plus 3 times 3.5 gives me 75.5. Is everybody getting that?
Yes.
Next one's a little tricky. It wants 1.5 standard deviations above the mean. So we'll take 65 and add not 3 times, but 1.5 times 3.5. And that gives me 70.25. These are right. If it says above, we add. If it says below, we subtract.
Yes.
So next question says the mean for adult men is 70 inches with a standard deviation of 4. The first thing that I asked folks to do on my pencil and paper test is draw a bell curve. So drawing that bell curve, for this situation, what should my middle number be? 70, beautiful. And when I go to the right and to the left, each time I should add 4. So 74 plus 4 is 78, plus 4 is 82. 70 minus 4 is 66, minus 4 is 62, minus 4 is 58. And then because it says 68, 95, 99.7 rule, I'm going to take the first one higher and lower, match them and label that 68%. Then the next ones, I'll label 95%. And then the last one, I'll label 99.7%. And again, there's no reason to memorize those numbers because when you're going to do it this way, they'll tell you to use the 68, 95, 99.7 rule. Now we're going to use that to find the percent between 70 and 74 inches. So between 70 and 74 would be this region. Oh, it's not a whole box. But isn't it half of one of my boxes? Isn't it half of the region for 68%? So I'm going to take that 68% and divide it by 2 to get that 34% would be between those heights.
Can you go over that part again, please?
Okay. This graph that we drew told me that between 66 and 74, it will be 68% of men. But 70 isn't the border there. The 70 is the line down the middle that cuts it in half. It's symmetric about that. And so if this whole region is 68%, I'm only taking half of it. So I'm going to take that 68% and divide it by 2 to get 34%. We're only looking at one side of that 68% box.
I don't get it.
Okay, are you all right with the idea that between 66 and 74, I'll have 68% of the men?
Yes.
Okay. So now if I want that line 70, we said was down the middle and it cuts the whole graph in half.
Okay.
And so the line 70 is going to be taking my whole region. Oh, this is not an orange line. That's stupid. It's going to take this 70 takes that region, and if it's the line down the middle, it cuts it in half.
Okay.
And so if I look at taking that 68% and cutting it in half, each side would be half of 68 or 34%. And so between the 70 and the 74 would be half of my 68 or 34%. Better?
Understood.
Okay, good. Next one asks for the percent between 62 and 78. And this one's kind of user-friendly because 62 and 78 match up. And on my graph, they match up to be my 95%. And so the last part asks what percent are below 62%. And below 62% would be everything to the left of 62%. Well, that's outside my 95% box. So I'm going to take 100 minus 95. But then we have to be careful because 100 minus 95, that 5% would be outside the box on both sides. And since we only want one side, we'll divide by 2. And so 5 divided by 2 will give me 2.5%. Again, when you see the word below or when you see the word above, you're going to take the percent that it's a border of and subtract from 100. And then because we're only looking at one side, we will divide by 2. Then, next one, this one's kind of tough to go over because I got a little creative with this question and I thought, you know, we're doing all this stuff with the mean and standard deviation about random numbers. You might be interested in what the percentile is for your height. And so I asked everybody to using the mean and standard deviation of heights from question 5 if you're a woman or question 6 if you're a man. What's the z-score for your height? Round to the nearest 10. So I have no shame. I'll use my height. I'm 4'11", which would make me 59 inches. Because I'm a woman, I'll use from question 5 that the mean was 6.5. No, it wasn't. It was 65. I apologize. And the standard deviation was 3.5. And so my z-score will be 59 minus 65 divided by 3.5. 59 minus 65 equals, so that's negative 6 divided by 3.5 gives me negative 1.7 to the nearest 10th. In my labs, they won't ask you your own height. They'll give you somebody else's number to use. Now, using the table on the last page of this test, in my lab, the table will be built right in. What is the percentile of your height? If the z-score is not in the table, use the closest value. So here, my z-score was negative 1.5. So on this table, I'm going to look for negative 1.5. And so my percentile is 4.46. So you guys, I'm proud to say that I am taller than 4.46% of the women. And that was what we spent a bit of time on last week, going through and using that 68, 95, 99.7 percentiles on the bell curve and finding z-scores and looking up the corresponding percentages in the table. You guys all right? Then the next one. Go ahead.
No, I'm fine.
Okay. Next one, I guess this must have been from last fall. It says a Gallup poll of 3,000 adults shows that 62% of Americans have worked from home since the COVID-19 crisis. I must have updated this question. Usually when I write this test, I look for something interesting on the Gallup survey website. So our sample size is 3,000. So our margin of error is 1 over the square root of 3,000 times 100%. And so to the nearest 1/10 of a percent, I get 1.8%. And so now for my statement, I'm going to look at that 62 plus 1.8, which would be 63.8, and 62 minus 1.8, which would be 60.2. And again, in my labs, that's all you need to do. But the statement will ask that you'll be filling in. It will say that we're 95% confident that between 60.2% and 63.8% of Americans work from home. Is everybody all right with that margin of error statement question?
Yes.
Yes.
Good. Then next, last question says scores on an IQ test are normally distributed with a mean of 100. So 100 is my X bar and a standard deviation of 16. S is 16. Use the Z-scores in the table below to find the percentage of people with an IQ. When it asks for the percent below, we're just going to use the table value. And so the Z-score formula from the preceding page is my value minus the mean divided by the standard deviation. So that's going to be, our value is 112 minus our mean is 100 over the standard deviation is 16. So that'll give me 12 over 16, which is 0.75. And so now I'm going to shift my paper. If my Z-score is 0.75, I have 77.34% as my percentile. And again, that percentile is always the percent below. So here the answer would be 77.34%. Next one's tricky because it asks for the percent above. And when you see the percent above, it's always going to be 100 minus the percentile. So first we'll find our Z-score, which our data value is 92, minus our mean is 100, over our standard deviation is 16. So that gives me negative 8 over 16, or negative 0.5. From my table, negative 0.5 is 30.85%. But that's not my final answer. For my final answer, because I'm looking for above and the percentile is below, we'll subtract from 100, which will give me 69.15% above. And then if a question asks between, remember for between, we subtract the percentiles. And when I wrote this test, I figured at this stage of the game, everybody was tired of finding Z-scores and percentiles. You did it a couple times already. And so I thought you could recycle the answers. The percentile for 112 was 77.34, minus the percentile for 92 was 30.85. And so when I do that subtraction, 77.34 minus 30.85, I get 46.49% between the two. And that's the end of my old school pencil and paper test. If the MyLabs test is comparable questions, how do you feel? Good? Okay. Again, this is posted in Blackboard, so burn these results, go through and try it again. And the answers will be scanned in with today's notes so you can check it before you take the test in MyLab. One more thing before we take a break. Wouldn't be done with the unit if you didn't have a project. I'm I'm giving you until April 13th for this project. So, you have a while to do it. When the project I used to use asked people to survey 10 people and come up with their own statistics. But last spring, with COVID rules, I figured I probably shouldn't be sending people out to survey. Probably not a good idea. So instead, I'm asking you to go to either the Buffalo Sabres or the Buffalo Bisons. Actually, let's change that to the Bills or the Bisons. Or if there's some other team you like, you can go to their webpage and get their statistics. Or if you don't like sports, you can go to some other webpage and get just 10 values. I chose those two because I think that most people in New York are interested in one of those teams, and that data is not hard to find. So if I can just get this stupid toolbar out of the way, let's say, for example, if I Google up the Buffalo Bills, it'll take me to their website. And on the Buffalo Bills website, if I go to team, I can go to statistics. But even here, they have some statistics. They have their heights, they have their weights, they have their ages, they have their experience, years in the league. If any of those float your boat, you can take 10 of those and you can pick which 10 players you use. Or if you're more serious about the sports, you can go through here and look at player statistics and find, I think there's 10 people with rushing numbers, there's, at least 10 people with receiving numbers and the like. So just pick 10 numbers from there. Instead, if you're a hockey fan, if you go to the Buffalo Sabres, you can go to their homepage, and there, right in this top toolbar, there's stats, and you can click on stats, and they'll give you all of these statistics for all of the players. And if you're a hockey fan, you know what all that stuff at the top means. I'm not really a hockey fan, but I somehow married a hockey fan, and all my kids are hockey fans. So, pick whatever information, is most interesting to you. And again, I'm just looking for you to take 10 data values. Doable? Then, once you've got your 10 data values, coming up with the 10 numbers is 4 points. Just telling me what the numbers are and what they mean. Then I want you to make a histogram and a stem and leaf diagram. So you're going to be making 2 graphs. The 2 graphs will be worth 6 points. Then I want you to find the mean, median, mode, and mid-range. That section will be worth 6 points. And then you get to decide which you think is the best description. And then find the standard deviation. What does it tell you? If the standard deviation is small, all the numbers were close together. Standard deviation is large, there's a lot of spread in the data. Turn it all in and write, when I say a brief report, I'm looking for a paragraph saying what it all means. Okay? Again, I thought it was more fun for students if I told you to just survey people and come up with your own data. But again, during a pandemic, I don't feel right sending people out into the world to ask 10 people for interesting information. I guess you could do it through social media, but okay, so that, folks, is the end of statistics. and we're about halfway through the class. It's just about 7:30. Let's take a somewhere between 5 and 10 minute break, and let's come back at 7:35. Okay? I'm stopped printing up a class, full class, 7 papers fast, because I end up recycling most of them. Today I got maybe 5. I still made way too many. Here, I'll be back in a second. This next one is, what we got percentages in there? Yeah, consumer math. So we're gonna look at percentages, we're gonna look at interest rates, then we're gonna look at compound interest rates, then we're gonna look at annuities. Okay. Then we're gonna look at car loans, then we're gonna look at mortgages. COVID rules, I've cut a couple things out because somehow teaching via Zoom, time is a little bit more, whatever. We used to also look at just reading the stock market listings so that people know what all the abbreviations are for.
I'd like to learn more about that.
So, well, I'll tell you what, did you get a copy of the book?
I do, I have a book.
Okay, it's all in there. Read it, it's interesting. So, and at one point in time, we were told that we had to do the statistics and the probability, and we were given a choice of another chapter. And I know a lot of my coworkers chose algebra. One of my coworkers chose logic, but I chose consumer finance because I wish somebody would have shown me all of that stuff before my husband and I bought our first house. So I'm thinking it probably is useful.
Oh, yeah.
If anybody took the business math, a lot of what was in the business math is in this section. So
Oh, that's good, I'm looking forward to that.
yeah. And so we finished with it because most people actually kind of find it the easiest part. The only thing is, at some point in time, in order to find mortgage payments and the like, we're not looking them up on a table, we're using a formula. And so, so I can give people partial credit. I ask them to write the formula, write what they substitute in, write what it looks like when you substitute. Because after that, it's just typing it into your calculator.
Right.
And so the writing things out on a 10-point question will be 9 of the 10 points. And what you get typing will only be 1. Because I know people do have problems inputting some of it into a calculator.
Right.
So, yeah.
Now, do you only, teach contemporary math, or do you?
No, I teach the gamut. There are some semesters where I'm teaching 6 classes and they're 5 different preps. I teach consumer math. I teach math for early education majors. I've taught the different levels of foundations classes. I've taught intermediate algebra. I've taught advanced algebra and trig. I've taught calculus. I've taught statistics. So, yeah, but you know what? After this semester, I'm hanging up my hat.
Are you?
Yeah.
How
Yeah.
many years do you get it?
This is my 14th year at the college. This is my 20th year as a state teacher. This is probably my 35th year teaching. I started, my first full-time teaching job was in 1982.
Wow.
So, a couple years out of college, right out of college, I decided I was going to change the world. And so I was a VISTA volunteer. And so I worked as a community organizer in the Midwest, in Des Moines, for a couple of years before I actually went and taught. I learned more in those 2 years than I did about what matters in life than I did in all my years of formal education. So it was amazing too. At that point in time, it was back when interest rates were like through the roof, and farmers were paying like 25% interest, and they couldn't. And so one of the jobs that I had was to organize. We were part of a national group that had won public hearings with the head of the Federal Reserve. And so I had to organize a hearing with Paul Volcker from the Federal Reserve. Yeah, it was interesting. It was such an interesting year. Initially, when I came off of that, I thought I'd stay a community organizer and not fall back on the teaching degree. But I fell back on the teaching degree, and the rest is history.
Yeah, it's great.
Yeah.
Do your girls want to be, or do your kids want to be teachers, or?
Well, my kids are all grown up. My oldest was very political and went to the University of Chicago and was a poli-sci major, and worked on political campaigns for several years. But got to the point where, you know, when after the campaign's over, you've got to find yourself a new job.
Yeah.
And had gotten from somebody that he had worked for a good position in Chicago, in the City Hall. And then that was when the economy fell apart.
Yeah.
And the housing prices and everything, and so his position was accessed. And so now he and his wife live in Baltimore, and he's a letter carrier.
Oh, wow.
My middleist works for Geico. She tried out very many colleges, and that formal education wasn't necessarily her thing. She did get her associates from here. And so now she's working at Geico. And my youngest, I don't know where she came from. She likes chemistry. And so she's a chemistry high school teacher on the other side of the state. So, yeah. 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 How about your kids?
Oh, my oldest son, he graduated from Edinburgh University.
Well, where is it?
Where is it?
Yeah.
Erie.
Okay.
Yeah, he studied college football, and he took criminal justice, and right now he's a case manager for a city mission in that, so.
Oh, cool.
And he's taken different civil service tests to get into like law enforcement and that.
Mm-hmm.
And then my son Michael is in his last year at UB.
Okay.
He has 4 spots cancer.
Oh, wow. Great job, but they're few and far between.
So, and my daughter Caitlin, she just graduated from community and she's been upstate and she wants to be an art teacher.
Okay.
Yeah, she's very artistic and loves to paint and.
I'm in awe of talented people, you know? It amazes me, so,
So I'm blessed. I have great kids, so.
yeah.
I work for I'm in agriculture and I'm a secretary and, I work, at DPW, so I've been with them for about 9 years. My husband's, he's a city electrician and he's on the board of education.
Okay,
He works with the school board,
cool.
so.
Very cool. For a while, I was the college's representative for the, I can't remember the official name of it, but in Niagara Falls, what they do for the education points, the professional development for the teachers. Yeah, I was involved with that for a little while, so during my term here. So, okay, folks at home, are you all back?
Yes.
Okay, we are now switching gears. We're in that final unit. I have to remember, before next class to upload PDFs of the homework for those of you who don't have, my lab. We're gonna start looking at consumer math. And the first thing we're going to look at is the idea of a percent. And gonna go on the assumption that you've probably heard of percents. Some people are probably very proficient with them, some are not. And so we're gonna take a, not too slow, but not too fast. When I look at that word percent, I'm not really a grammar person, but I look at that word and I see a prefix in a row, root. Per means part of. And if I look at cent, let's think about where you see that word cent. In money, how many cents are in a dollar? 100. In how many years are in a century? 100.
100.
How many centimeters are in a meter? 100. That root cent means 100. And so percent means part of 100. And I've heard people say that slash almost makes it look like you've got a fraction bar. And if we move the zeros, it's a fraction over 100. And so if I have, for example, 30%, that means the fraction 30 over 100. And we can divide that to a decimal, which will give me 0.3. But before we get too far into percents, let's do a little bit of arithmetic brush up. And let's look at just taking fractions and expressing them as decimals. And I'm thinking that everybody knows the fraction 1/2 as a decimal is 0.5 or 0.5. But to change a fraction to a decimal, is everybody familiar with the idea that you take the numerator and divide it by the denominator? Remembering that those are the parts of a fraction. When I see a fraction, the numerator is the number in the top, and the denominator is the number in the bottom. And so if I wanted to write 4/5 as a decimal, what would I get? Nobody's got a calculator out. 4 divided by 5 gives me what? 0.8. What if I have 7/8? What will that give me?
0.875.
0.875. Great. What if I have 2/3? 2 divided by 3 is going to give me 0.66666666. And does everybody remember at some point in time in their life learning about repeating decimals? And if you put that bar over, it means repeat. But if I were asked to round to the nearest 100th, is everybody all right? That would give me 0.67.
Yes.
Instead, if I want to take a decimal and change it into a fraction, I'm going to put the digits of the decimal over the place value of the rightmost digit. And so let's take a minute and look at those place values. This would be in my ones place. And then as I go to the right, is everybody all right? This would be the tenths. The next would be the hundredths.
Move the paper up, please.
Oh, sure. I'm sorry. The next would be the thousandths. The next would be the 10,000ths. Or the number of places I am behind the decimal point is the number of zeros in the denominator. So for example, if I ask you to express as a fraction in simplest form, if I have something like 0.375, the furthest to the right is the 5. It's 3 places behind. So that means I'm going to put 375 over 3 places behind would be putting it over 1,000. And now I've got to reduce. You can probably reduce that with your calculator. I'm going to do it old school. I think both numerator and denominator can be divided by 25, which gives me 15 over 40. And I think both of those can still be divided by 5. And so that gives me 3/8. I guess I'll check the cheater's way. And it's not really cheating, the calculator way. If I put in my 0.375, I'm going to go second, and that FD means fraction to decimal. Oh, I didn't want a multiplication. I wanted just second FD. And so, yeah, it gives me the 3/8. That should work for a lot of them, not necessarily all, but
Can you-
for a few.
Quick question.
Calculate.
How did
Go
you
ahead.
do it on the calculator again?
How did I do it in my calculator?
Yes.
I typed in my
Go ahead.
I typed in my decimal 0.375. And do you have a calculator like this one?
Yes, exactly like that.
Okay, so I'm pressing the pretty purple second button. And when I press that, it means I'm looking at the things that are written in purple above the button. So do
Okay.
you see how this one says Sci-Eng? And do you see
Yeah.
how this next one has F arrow D?
Yes.
F arrow D changes the fraction into a decimal, or it changes the decimal into a fraction.
All right. Understand now.
Okay, thank you for asking. And so let's try another one. Let's try to write 2.36 as not a mixed number, but as a fraction. My digits are 2, 3, 6, and my 6 is over the 100th place, so I'll put 236 over 100. And let's see, they're both even numbers. If I divide by 2, that gives me 118 over 50. And if I divide by 2 again, that gives me 59 over 25. And I don't think it reduces further than that.
You divide them by 2 because you only moved over 2 decimal spaces.
No, I divided it by 2 because I'm trying to reduce this fraction. And when I'm really lazy, when I reduce a fraction, if both the numerator and denominator are even numbers, I can divide by 2.
Oh, okay.
Okay? Remember, to reduce a fraction, you have to divide top and bottom by the same thing.
Okay.
Although I think with the calculator, if you used your fraction key, let's see if this works. We've got 236. I'm going to use my fraction key, that ABC key, and I'm going to put that over 100. And see, it changed it into a mixed number. And so if I want to change that mixed number into just a fraction, I'd have to go second ABC, and it'll change it into improper fraction. And at that point, I think that for me, that's too many buttons to push. So I do the old school thing and just reduce it by hand.
Yeah, understand. It looks a little bit more.
Yeah. Then, again, to change a percent into a fraction, we just write the percent over 100 by definition. So if I have 25%, that would be 2,500. And I'm hoping everybody can reduce that. When you reduce that fraction, what do you get?
1/4.
1/4. Beautiful. Instead, if I have 13% as a fraction, that would be 13 over 100. And I don't think that one reduces because 13 is a prime number. If I have 230%, again, to change that percent into a fraction, I'm just going to put it over 100 and then reduce. And I think because they both end in 0, I can divide by 10 and I get 23 over 10. Next, if I want to change a percent into a decimal, putting it over 100 means that we're going to divide the percent by 100. And so if I have 15%, I'm going to take 15 and divide it by 100. And so with your calculator, when you take 15 and divide it by 100, you get 0.15. Instead, if I had 3.5%, if I take 3.5 and divide it by 100, I get 0.035. And if you want to change a percent to a decimal, you can always divide by 100. But after you do those that often enough, you notice that the digits stay the same and all it moves is the decimal point. So we could also, dividing by 100 is the same as moving the decimal 2 places to the left. And so if I have 59%, in my 59, if it's not written, the decimal point is at the end of the number. When I move it 2 places, I get 0.59 as my decimal. If I have 160%, moving that point 2 places would give me 1.6 as my decimal. And so if I'm going the other way, from a decimal into a percent, I'm working backwards. So I can either multiply by 100, or that has the effect of moving the decimal 2 places to the right. So if I have 0.75, I could either think of taking that 0.75 and multiplying it by 100, or moving it 2 places would give me 75%.
Now,
If
is it
I
always-
have,
or- I just had a quick
Pardon
question.
me?
Is it always 2%? I mean, 2
2
spots over?
places, yes,
Yes. Okay.
yes.
So this is our
Multiply
formula.
and
Either
divide. Right. You have a choice. You either can multiply it by 100,
okay.
if you're more comfortable doing that, or most people find it easier to remember, I'm just moving that decimal point 2 places.
All right. Thank you.
So if I have 0.675, moving it 2 places would give me 67.5%.
All right. Thank you.
And what if I have 0.007?
Would it be 0.7?
0.7%. Beautiful. And using 0.007, that's my James Bond reference. Never mind. And what if I have 2.5? What would that be as a percent if I move that 2 places?
250%.
250%. And if you have a number that's bigger than 1, you'll always have a percent larger than 100. Because 100% is 1. And so if we're comfortable with that, we're going to look at how to find a percent of a number. And I know there are several ways of doing this. I know there are some people who, in middle school, learn something like is over of equals percent over 100, cross multiply and divide. But in my mind, that's too many steps. So what I'm going to do is I'm going to translate. Going to translate the sentence into an equation. In order to do this, you have to express the percent as a decimal. So you have to change a percent into a decimal. Then you have to remember the verb is means your equal sign. And you have to remember that the word of means to multiply. And the word what will be your variable. Most people like X. So those are the rules that I like to use. That's my favorite method. So let's say I have a question that says, what is 15% of 30? I was never good with foreign languages, but we're going to treat this almost like a foreign language, translating one word at a time. What becomes my variable? Is becomes my equals. I want my percent as a decimal. And now I'm going to multiply it because of means multiply. And so when you take 0.15 times 30, what do you get? And I don't know about you, but to me, that's easier than all of that proportion stuff. Next example. What is 12.5% of 48? What X is means equals 12.5% is a decimal is 0.125 of means I'm going to multiply it by 48. What's that give you?
5.76.
6.
6?
Oh, that's right. Oh,
Next example. An item costs $40. The tax rate is 8.5%. How much is the tax? hopefully everybody's been shopping enough to realize that the tax is the percent, 8.5% of whatever your cost is. And so here, the tax is what we're looking for, is equals 8.5% as a decimal is 0.085 of means multiply by my cost is $40. And so when we multiply that out, what do we get for our tax?
$3.40.
$3.40? Will this one fit here? Well, I'll turn the page so we're not smushing in. Next example. Let's say that shoes cost $80. They're on sale for 30% off. We want to find what's the discount. And then we want to find what's the sale price. Oh, if it's 30% off, is everybody all right with the idea that the discount is 30% of the price? The discount's what we're looking for is equals 30% as a decimal, decimal is 0.30 of means multiply. My price is 80. And so what's our discount? $24. So then what should I do to find my sale price?
Subtract from the total.
The sale price is the original minus the discount, or it's going to be the $80 minus the $24. And so what a deal. We'll get these shoes for $56. And to this point, we've been looking for the amount of the percent, but we can use this to find other things. We could say, for example, 30 is 15% of what number? $30 is means equals 15% is a decimal is 0.15 of means I'm multiplying by what is my variable or x. So 30 equals 0.15 times x. And does everybody remember, if we just have a coefficient on our variable, we're going to divide both sides by that coefficient, by the 0.15 to find x. So I'm going to divide this by 0.15, and I'm going to divide this by 0.15. Here, anything divided by itself is 1. And so when I take 30 and divide it by 0.15, what do I get?
200.
200. Next one's a little bit different because the next one asks me to find a percent. And I like to consistently use this change it to an equation and solve method. And so to find a percent, I use P for my variable so that I remember to change the decimal into a percent. So what's that all about? Let's say I want to know 15 is what percent of 75? $15 means equals. Since my what is the percent, I'm going to use P, and that's times 75. And then just like with the preceding one, to get the variable alone, we're going to have to undo multiplying by 75. And so I'm going to rewrite this. I'm going to divide both sides by 75. Which gives me P is, what's 15 divided by 75? 0.2. And so that would be 20%, changing that decimal to a percent. And so a word problem that might ask you to use that type of skill might be something like an item costs $30. The sales tax is $2.25. What is the tax rate as a percent? And what we have to remember is that idea that the tax is a percent, what percent of the cost. So here, my tax is $2.25. Is means equals. I'm looking for a percent, and my cost is $30. Again, because I'm multiplying to get the P alone, we'd have to do the opposite or divide both sides by 30. And so what do you get when you take 2.25 and divide it by 30?
0.075.
0.075. And so that would be, as a percent, move it 2 census, 7.5%. And so do you see how if you can write it as that sentence, is means equals, of means multiply, and you need your percent to be a decimal, so then you've got to work backwards from the decimal to a percent. There is a part in this first homework in chapter 8, we're going back to chapter 8 from chapter 12, that talks about the percent increase or decrease. And to find the percent increase or decrease, we're always going to find the change or difference. Which means we're going to subtract. And to get the percent, we're going to divide the difference by the original or starting value. So for example, let's say an item that's regularly $80 is on sale for $50. What's the percent decrease? So the difference here would be 80 minus 50, or $30. And now what was the starting value? Did it start at $80 or did it start at $50? The difference over the original or initial would be that 30 over that 80. And when you divide that out, what decimal do you get? And so change that into a percent. $37.5%. Next example. Let's say a store buys an item for $40. They sell it for $55. What's the percent increase? So first, let's find the change or the difference. Which would be 55 minus 40, or 15. And then we want to put the difference over the original or the starting. And so it started at $40 and went up. So we'll put that 15 over that 40. And when you divide that out, what do you get?
0.375.
And so this would be a 37.5% increase. And that's that first section of chapter 8. That's that homework. Let me double check. I think it's that homework 18. Let me just real quick double check. Actually, no, it's not homework 18. It's the next homework that you're doing, which is homework 20. We're skipping homework 19. And so that's that homework 20 that will be due on it's the 7th. Why do I have it as the 14th? That should be due on the 7th. It helps if I change the right one. And as much as I want to keep going to simple interest, I'm looking and I'm thinking that because in between now and next class, I'm asking you guys to take it. Okay, I'll change that later. I keep hitting the wrong button. Let me go back here. I'm hesitant to go further because you've got that test in between, and I don't want to pile on too much new stuff before you get that test. But it's early. Would it hurt your feelings if we ended class early? No. Did you want to do more of this consent stuff, or do you want to wait until you finish that last statistic? So I'm going to make a note that we're stopping here. And next week we'll go full blast into simple interest and compound interest, and maybe from there even into annuities. Okay. So, folks at home, will it disappoint you terribly if we call it a day? I think I adjusted attendance and got everybody already. So, everybody have a great night. Make sure you take that test. It's in my lab. Make sure you submit your work in Blackboard so I can give you partial credit. And if that's all right, I'm going to call it a night. So, have a great one, you guys.
All right, thank you. You too.
All right. Bye-bye.
Bye-bye.
Bye. I have a question.
Sure enough.
I missed the first half, so is the test tonight?
The test will be available, I think, starting tomorrow. And you just have to take it before next class. You just have to take it before Tuesday, the 6th. Good night.
Okay, thank you.
Okay? And make sure it's in my lab. And make sure you submit pictures of your work in Blackboard. Okay? All right. Bye-bye.
Hello, I have a question.
Yes?
Can you PDF the homework?